Welcome to my channel. So in this video I am going to explain the 8085 microprocessor programming. In that we are going to see 8-bit addition. So before going to design any type of program, you must know the manual concept for that one, right? So here 8-bit addition. So addition indicates what? Basically you need two operands. For example, A plus B, right? So A is one operand and B is one operand, and the processing operation what? Addition, right? So this is what addition operation. So first we have to get the input data, that is first data, okay, and second data, okay, first data, second data. You after that you have to process something. So processing is what? That is addition. So after processing is over, you need to see the result. Okay, so this is the basic manual operation for any type of addition. Okay, now let's move on to programming. So here I am going to do this program in two ways. One is a simple programming and one is what? User defined programming, right? Now I am going to write the first simple programming. I am going to explain. So I am going to tell what is the difference. Okay, so here I am going to use here MVI A comma 05. So MVI A comma 05 indicates, so here the immediate data, direct immediate data is given. See, immediate 05. Here 05 is already given. See, MVI indicates immediate data. MVI A comma 05 means what? So this 05 data is moved to accumulator, right? Next I am going to move this data into some other register. Move B comma A. So move B comma A means, so whatever the content which is present in the accumulator, whatever the result, data which is present in accumulator, that copies that data into B register, right? Now I am going to take the another data, that is move MVI A comma 06 or 04, whatever you want. Okay, that is immediate data, right? So now first data is moved to B register, and second data. So second data is available at what? A. So at this point A is equal to 05. At this point, that is B is equal to 05 as well as A is equal to 05. Okay. At this point, A is equal to what? 04. Right? Now, so first data. So two data are there. One data is available at A and one data is available at B. Right? Now I am going to add. Okay, there is add instruction. There is add B. So add B is what? Processing. So now the first two inputs are over. I need the processing over here. So processing is done over here, right? So add B indicates this, the meaning of this instruction. The meaning of this instruction is accumulator. That is A is added with B. So whatever the content which is present in accumulator, that is added with B register, and result will be stored in accumulator, because the accumulator is always associated with ALU of the microprocessor, right? So here what is the output? Here you will get what? 04, and here 05. You will get what? 09. Okay, so 9 is the answer, right? Now the data is available. Where it is available? That is accumulator. So you have to store the data to see the result. So for that purpose I am going to use here. So STA 4300. This 4300 is one memory, that is external memory. So external memory address, this is what user defined address. You can, based on the whatever the memory device you are going to use now, so in that particular address you have to store. So STA 4300. Then hard, so HLT. So here 4300 indicates, so some memory. So some memory is there. This is the memory device. So for example 4300 memory slot. So in that memory slot, so the output is what? 09 is written. Okay, so STA indicates store accumulator content to 4300. Okay, so this is what? Fixed variable. So this is the addition program for fixed variable. So you cannot change these values. So it performs only the addition of 05 and 04. The addition of 05 and 04. So this is not reliable system. Okay, if you do the only a fixed variable addition, so that is not a reliable system. It is not fit for what? All values. Okay, now in the next program I am going to design the reliable program. Okay, so you can give any type of 8-bit data. So for that 8-bit data, so you have to addition operation can be carried out for the following data. So that is the next program. Okay, now I am going to write that program also. Now I am going to write the program. So here I am going to take the data from what? Memory side, right? So here for example, first here in the binary addition, you have to think over here binary addition. So after taking first data and second data, some addition operation is carried out. If addition during binary addition, so addition, so there is a concept of what carry. So that is sum result and carry result. Okay, so we have to store both sum result as well as carry result. Okay, that is also you have to keep it in mind. Okay, first you just list the what are the components are required before designing the program. Then after that, you just based on that components, you just transfer that manual concept into programming concept. Okay, now here, so two operands are required. Then processing is there. In processing, whether the carry is there, carry and okay, carry concept. Okay, carry concept you have to check. Then after that, you have to store carry and sum, right? And you have to store the result. So okay, these are the points you have to keep it in your mind. Okay, before designing any type of program. Okay, now I am going to initialize here MVI comma 00. So 00H. So 00H indicates. So I am going to initialize the C register as 00 for storing carry, because I need to store the carry if carry is generated. So I want to see the carry result also in the memory location, right? Now I am going to use here LDA, first data. First I am going to take the first data in the memory, LDA 4100. Okay, so for example, assume the memory look like this. Memory has different slots. Okay, these are the different slots. So here actually 4100, 4101 and so on. So many memory locations are there. So I am going to use here first data, for example 03. Okay, 03 is there. So LDA 4100 indicates whatever the content which is present in 4100 memory location is loaded. LD means load. Okay, LDA. So LDA 4100 means whatever the content which is present in 4100, that is loaded into accumulator. That is A. Okay, so this is what instruction. Okay, now one data is loaded. One data is loaded into accumulator. So I want to move that accumulated data to another register. Okay, why I want to move that I will tell you. Okay, so move B comma A. So move B comma A indicates whatever the content which is present in A, that is moved to B register in order to get the second data, because so for memory access, for accessing memory only, the register is available what, that is accumulator. Okay, because only the instruction we are having what, LDA, we don't have what, LDB instruction. LDB instruction is not available, only LDA instruction, that is the memory data can be accessed, that is memory communication can be done through only accumulator, not any other register. Just you have to remember that one, right? So there is no LDB instruction or LDC instruction. This type of instructions are not available, because so only the communication between memory to CPU is what, through accumulator only, right? So that's why, so for the first data I am taking into accumulator, I am moving that data into some other register to get the another data, right? Now LDA 4101. So this indicates whatever the second data, I am assuming here 05. So whatever the second data which is available in 4101, that is loaded into accumulator, right? Okay, now the first data is available at what, B register, and second data is available at what, A register. Now two data is over. So these two data is over. Now what is the next process? So you have to do the processing operation. What is the processing operation here? Addition. So what is the addition instruction here? Add. Okay, so add B instruction. So add B indicates, so already I explained. Okay, so A is added with B register. So accumulator, that is accumulator is added with B register, and result will be stored in accumulator. So at this point processing is over. So after processing only, you have to check whether the result is, whether the carry is generated or carry is not generated. If carry generated means what we have to do. If carry is not generated means what you have to do. So that you have to think, right? So now I want to check the condition. Jump no carry loop. So some loop, some loop is there in the program, right? So jump no carry means, if no carry means go to loop. If carry is not generated, while adding these two data, if carry is not generated means go to loop. Okay, store the result. Okay, if in case if carry is generated means what I have initialized here for carry, C I have initialized the carry, right? So if carry is generated, you have to use here INRC. INRC indicates that C is incremented by 1. Okay, because the carry flag is what, either it is capable of storing what, 0 or 1, only two possibilities, right? Now if jump no carry means go to loop, right? If carry is not if carry is generated, so what you have to do, INRC, then you write here STA 4300, that is memory location. Okay, if jump no carry means come here, okay, look, now you just put here. Okay, see here, if jump no carry means directly you just store this accumulator content to 4300. Okay, this step is skipped, right? And so here so now the resulting data, some result is available what, 43. For example, I am going to assume here the memory location 4300 is available. Okay, so at this point you are having the data 03 plus 05 is what, 08. Okay, now store the some result is stored, and also I want to see what carry result also, right? So for that purpose I am going to use, again I am going to move A comma C, because so already I told, no, so in order to communicate the memory through accumulator only you have to communicate. So first you have to I am storing the data, that is carry result in the memory 4301, right? So in order to access this memory location, so you have to move the first C data to accumulator, then you just take STA 4301. Okay, now the carry content is available over here. Okay, so here carry is only 00 only, because it won't produce any carry, right? Then halt indicates what, that stop the program. Okay, so if halt instruction is executed, whatever the instruction after the halt, if whatever the instruction you are going to write, it won't execute. Okay, this halt is that is end of the program. Now let's move on to what, iteration. Okay, iteration. Okay, inside what is there actually, what will happen, that I will explain. See here, at this point move MIC, 00 means C is equal to 00. Here LDA 4100 means what is the 4100 content? 4100 content is what, 03. So that is moved to what, accumulator. A is equal to 03 at this point. Okay, next move B comma A indicates what, here A content is what, 03, so that is moved to B register. So at this point B is equal to 03, and also A also it copies, so it copies the data only, it copies the data, that's it, right? So A also 03 and B also 0. So at this point LDA 4101, at this point 4101 is what is our answer, 4101 is contains 05, so that is moved to accumulator. So now at this point it overwrites 03 instead of 03, that is 05. So now the updated value is what, 05 and 03, right? Next, so at this point add B indicates, so what is the B value, 03 plus A value 05, that is what is the answer, 08. Okay, so now accumulator contains what, accumulator contains A, 08. Now jump no carry, if no, here carry is not generated. Okay, carry is not generated, so jump no carry must go to loop here. Okay, so come to loop here. So store the accumulator content. So STA, what at STA indicates store accumulator content to 4300. LDA means get the whatever the data which is present in 410, that is loaded. So this side loaded into accumulator, stored into memory location. So STA 4300 means at this point A is 08, that is loaded into 430. So the value is what, 08. Next move A comma C indicates here 4300 indicates what, 08, right? And move C comma A. C, at this point C is what actually, C is 00. So that A is equal to 00 and C also 001. Now 4301, at this point 4301 is equal to 00 only you will get. Okay, so this is the basic program for 8-bit addition. Okay, this program will satisfies any type of variable. You can give the any type of variable, you can change the input variables also. Okay, so in the previous program only fixed values, so that program is fit for only fixed values, that is not reliable. So this program can be applicable for any type of variable, any input variable you just take, you can perform the addition concept. Okay, so this type of program program only we need, okay, for achieving the better reliability of the system, right? So this is the basic concept behind in 8-bit addition using 8085 microprocessor. Okay, hope you understood and enjoyed this video. So please like, share and subscribe this video. Thank you.